Well, I'd like to introduce myself first. I'm Sherry Timoni. I'm an associate professor in the Department of Natural Sciences in marine biology. And I feel very lucky to be able to introduce tonight's speaker for the Evening at Egan seminar series. First, I'd like to thank all of you for coming because it just shows such a great support, not only for marine biology via Dr. David Gallo, but also for our lecture series held here at UAS each Friday evening in the fall. And so just a heads up for next week, we'll have our own Jeremy Kane of the art department here talking and presenting about his images over the last 15 years, and it's entitled 15 Years of Clay. Okay, so be sure to come out for that if you're around here. Tonight, we're just very fortunate to have Dr. David Gallo come to us. He's here for this week's annual conference, Alaska Conference in Math and Science. So maybe some of you have heard his keynote address earlier this week and have been involved in this conference as well. If you have heard Dr. Gallo, you'll know he's a firm proponent of communicating science to all. So that's one of his emphases these days, is communicating sciences to the communities. I don't know Dr. Gallo, but I became involved in some of his work about 5 years ago when I was able to go to an IMAX film. I was attending a conference for the Society of Integrated Comparative Biology in Texas. And I was there with Dr. Tom Shirley, who some of you from this community might know. And we both have been involved in some submersible work. And he thought I might enjoy this little film on deep sea biology. Well, I was absolutely floored. I think it was analogous to watching a man walk on the moon back in the 60s, to see footage of hydrothermal vents miles deep down with absolute clarity. The videography was phenomenal. It also was so remarkable to see the diversity and scope of life living down in these deep sea vents. Excuse me. After that, I was my other interaction in a way with Dr. Gallo's work has been through a website called TED Talks. And Dr. Gallo gave a couple of seminars through this very popular conference series. You can access these on TED.com. But I was Googling cephalopods because I was giving a talk on octopuses, and I came upon a TED Talk by Dr. Dave Gallo, which was, again, a phenomenal videography of cephalopods in motion. So from that, I took away that Dr. Gallo is a great speaker, very charismatic. And so at this point, he laughs. At this point, I would like to just talk a little bit about Dr. Gallo. Just a little bit. He received his BS in geology from the State University of New York in Albany, and he liked it there so much he received his master's in geology, also from the same spot. Maybe against his better judgment, he went and got a PhD at the University of Rhode Island, and this time he was directed straight into oceanography. And he had, for some time, been deeply involved in seafloor mapping of the oceans. And he received his PhD. I have to admit, the same year I received my PhD, and I'm not near as famous as you, but probably not nearly as busy as you. He's received multiple honors and awards. I guess going back to the TED Talks, if any of you have been familiar with these, they're not all on science. They can be very different topics. It's really labeled riveting talks by remarkable people. And one of his talks was voted within the top 10 most cited seminars. And in fact, it placed third, which is quite an achievement. He's a co-recipient of the Smithsonian Award for the use of computer technologies in science communications. I'm only highlighting a couple of these. He's got like a huge CV, but I thought I'd give the highlights here. Dr. Gallo was a guest on Martha Stewart Radio. I thought that was kind of interesting. He was, he had a piece in Vanity Fair magazine in the green issue. And I don't know what this means, but he's a Breakfast Club scientist, and I kind of want to be one of those too. I think I'm going to leave the podium and give that honor to Dr. Gallo at this time. So please welcome me now in having Dr. Gallo here.
Thank you. I think I'm all set. Thanks. Oh, thank you. That's very kind of you. It's a real honor to be here. I have to tell you a little bit of the truth about myself, though. So I grew up in central New York, long way from the oceans, on the Finger Lakes, and like many people in my class and in my community, Auburn, New York, I thought the oceans were mud-covered and a few hundred feet deep. I knew from Jacques Cousteau that there were French guys in Speedos out there somewhere swimming around. So I didn't think much about the sea. And I have ADD, not only ADD, and you'll see on my slides, they always say Dave Gallo, ADD, PhD. One I was born with, one I earned. And I have a hard time reading. But when I was a student, all the way through elementary school, there was one book they made me read during the summer. It was Kon-Tiki. And that book I read 5 times, maybe 6 times, maybe 7 times. I read it again and again and again, and there was something about it that just caught me. I think it was the idea that there were people out there still exploring the planet. And in Kon-Tiki, Thor Heyerdahl got a team of people together. They built a raft out of balsa, and they sailed from South America to Easter Island. And he had a team of Norwegians, and I didn't have that, but I wanted to do that. So I had my neighbors, Jimmy Kukela and Alan Kowalski, and we didn't have balsa wood, but we had railroad ties. So we built this. Our goal was to sail across Owasco Lake, which was a mile, and we built this raft that weighed about 3,000 pounds, and it was terrible. We built it about 500 feet from the edge of the Owasco Lake. And I remember we spent a whole summer just trying to put a mast on the thing. It kept falling. I used all my mom's clothes poles. It was terrible. So eventually the raft fell apart and probably saved our lives before it got to the sea. Anyway, I stored that in the back of my head. And at the time, I wanted to go to space. And in fact, I just had the privilege in Dallas a couple days ago. I went from Dallas to Paris to here. But in Dallas, at a TED event, a local TED event, they had the podium from which John Kennedy announced that we would go to space, not because it was easy, but because it was hard. So they had that very podium on the stage. We couldn't touch it, but there it was. And I remembered what that speech meant to me, and I wanted to be an astronaut or an astronomer very badly. But my aptitudes in school and my tests, for sure, led my counselors and teachers to say I should probably do something more with my hands when I graduated than with my brain. And I did. I sold shoes for about 7 years after high school, and I loved it. I miss it. That's why I've been Vanity Fair. I've been in, hard to believe, but been in fashion shows. I still have this notion up here that I'm somehow involved in the women's fashion industry. But I was standing behind a counter like this one day in the shoe department, just like this, and I was flipping through a National Geographic, 1976, article by Bob Ballard, the guy that would eventually, 10 years later, he would find Titanic. And it was an article about him exploring a place on Earth called the Cayman Trough. And I remember there was a hand-drawn picture. I still have the journal behind my desk in my office. There was a hand-drawn picture of an underwater mountain, and it said, "This is higher than the Alps," and there was a little speck on it, and it said that was a submarine Elven, and they blew that thing up, and there was this little tiny submarine with 3 people inside it, Dr. Ballard and 2 other people, and there's something about that just threw the same switch in me that speech by John Kennedy, President Kennedy did. And I grabbed that magazine, and right across the parking lot was State University of New York at Albany. I didn't get suddenly smarter, I just got directed, and a passion got ignited in me. And about 2 years later, I was in that sub. I had my bachelor's degree, and I was on the bottom of the Pacific Ocean. And then a few years after that, got my master's degree. And then sometime after that, took a while, got my PhD, and then joined Bob Ballard. I got a letter from Ballard in '87 to come join him right after he found Titanic. at Woods Hole Oceanographic Institution as his assistant director. And so my dream had come full circle, and I remember the very first expedition in the Mediterranean with Bob Ballard. I flew into Gibraltar, got on the boat, and there was all these guys I had seen on TV, all the engineers, all the scientists, Bob Ballard, National Geographic cameras, and the question they asked right off the bat was, is it tough to go from selling shoes to, you know, this humbling, to working with the best and the brightest and studying the deep ocean? I said no, because in both cases, the same rule applies. It's after the first 1,000 feet or so, both jobs get a lot tougher. That's my joke. That's my joke for the day. Okay. So, Neptune's realm, exploring the ocean. Back then, we'd explored about 3% of what's beneath the sea. And today, many of you know that because here you have many people that are in ocean exploration and in the technology of building tools to go to the bottom of the deep. So they have that passion, and you know what I'm talking about, that we've explored very little of the ocean. So still that world is about the ocean part of it, 70% covered with water, is mostly unexplored. So we maybe explored 5%. My ADD lets me show this, which I wasn't planning on showing, but I thought I should show it to you. This is a program called Earth Browser, and you can get it on the web. It's a very fascinating program. I think it costs $20 or something like that, but it allows you to show Earth data in near real time, and you can do this kind of thing to the planet. There's the edge of night, which see, we're up here, and the edge of night says that we are dark outside. Yep. so it works pretty well. I can get rid of the, let's get rid of that. Okay. So now what we're left with are clouds, and we'll get rid of those too. Come over here to my little cloud clicker. Get rid of the weather patterns. And now what we've got on the planet are earthquakes and volcanoes. There's lots of other stuff you can show. And I was just noticing that here's where that big tsunami was, down inside here and here. And these are still very active today. There's some earthquakes. These are, in the last couple of days, some pretty big earthquakes, 6.2 and the like. So here, and the big one a few years back is right up inside here. So that's the Pacific Ring of Fire right there, surrounded by volcanoes and earthquakes. And there's all sorts of stuff you can plot on this. So it's pretty amazing. But you know, it gives you the impression that we understand everything that's going on the planet. And I'll show you in the coming slides that that's not true. I hope. Let's see, where did it go? Here we go. All right. So that was called Earth Browser. And see, just like I said, Dave Gallo, ADD, PhD. A little bit where I'm from, I work at Woods Hole Oceanographic Institution. And that's an aerial view of Woods Hole. 1,000 other people work there, and the deal with Woods Hole, like many other places, is that we're driven by the passion to explore, and mostly the ocean. 1,000 people, a couple hundred scientists, engineers, and support staff. And any given time, we have people on the North Pole, South Pole, mountaintops, river valleys, shallow water, deep water, all over the planet, all trying, like detectives, collecting clues about how the world works. Average depth of the ocean is about 2 miles, and you can't get there from here without technology. So, and the stuff that we use, you'll see in a moment, everything from submarines, scuba, robots, and the like. I'm just going to show quickly, this sums up what we do in four summary areas. Coastal stuff up on the left, that's the interaction between humanity and the sea, the direct interaction. Animals from microbes to whales. Deep ocean exploration, we're going to talk a little bit about that today, and climate change, we'll talk a little bit about that today too. This view from, talk about technology and space and all, this is from an Apollo, returning Apollo spacecraft coming back from the moon, taking that shot of Earth, and boy, that ought to stop us in our tracks as a species to be able to see where we live, to get off our planet, look back at home, wow. But, you know, it wasn't long before we start taking this thing for granted. You know, yes, it shows up on coffee cups and things like that. But this should mean an awful lot to us because it has allowed us a different perspective of how tiny this place is that we call home. That's the water stripped off, the atmosphere stripped off. And looking at the Pacific, just to show you, again, remind you how much of the planet's water. 70% covered with ocean, average depth about 2 miles. Hawaii is right up inside here. Let's see if, there we go. There's the Hawaiian Islands, but mostly water, okay, from that perspective anyway. Sometimes we call it the blue planet, sometimes we say it should be called planet ocean. And if you peek beneath that water, one of the things that stunned us early on was at the bottom of the ocean, there's a mountain range. So it's not flat and mud covered after all, but there's this incredible mountain range beneath the sea, and you can see it on there in the middle of the Atlantic and in the Pacific, and then over here in the Indian Ocean. That thing it winds around the world like the seams of a baseball. It's called the mid-ocean ridge. And this is something that we've known about for decades, but we still don't understand it completely. And we still just say, oh yeah, the tallest mountain range on Earth is beneath the sea. There are thousands of peaks on that mountain range that are higher than the peaks around us right now, maybe 2 times, 3 times higher than say, Mount Juno and the like out here along that mountain range. There's thousands of valleys that crisscross it, many times wider and deeper than the Grand Canyons, and thousands of times longer than the Grand Canyon. Okay, so the greatest mountains, greatest valleys on this planet are under the ocean. The tallest mountain on Earth, we say, is Mount Everest, but really, if you strip away the water, where's the little pointer? Way over here in the Pacific, Mauna Kea on Hawaii turns out to be higher off the seafloor than Mount Everest is above the surrounding land. So all these things beneath the sea and really stunned us. But I think the one thing that stunned people further is when you plot earthquakes and volcanoes on that map, kind of like what I showed before, but this is over time. Turns out that most of the earthquakes and volcanoes on the Earth are also beneath the sea too. And most of them fall right along the edges of what we call plate boundaries. This is the idea of plate tectonics. You know it well here in Alaska, because plates move very slowly. You know, Africa used to be against South America and North America and moved apart about the same rate your fingernails grow. But what reminds us are earthquakes and volcanoes, those little reminders that plates are constantly moving. So, say the unexplored world we call home. So here we are living on this planet, and out there around us is this unexplored world full of mountains and valleys. Not only that, but we also find rivers in the ocean. We call them currents. And you're familiar with currents at the surface, but even deep in the ocean, those are warm water currents up at the surface, warm water rivers, if you will. At the bottom of the ocean, you have to have a return flow, so we have cold water currents. And these things turn out to be very important to things like climate change. And so we have rivers in the sea. We also have lakes in the sea. I know it's hard to believe, but there's places in the ocean, at the bottom of the ocean, where you dive down in a submarine, come across the bottom, and there's a shoreline, and then a separate body of water at the bottom of the ocean. That's like a little lake beneath the sea, except it's super salty. It's not salt water. I mentioned the technology, and that's the most famous one we have. This is our ship Elven, our submarine Elven here. 3 people are inside. Those are divers just checking out the sub to make sure it's okay to dive. And the support ship Atlantis in the background. So about 50 people go to sea. It's not one person that's waving around a PhD. 50 people, half of them ship's crew, that take care of being out at sea. It's still as dangerous as it ever has been. And the rest scientific team. So teamwork, teamwork, teamwork. And this is a typical Elven launch. There's Atlantis in the background. Now it doesn't have all the rumbling and stuff that a space shuttle launch has. But to us on board that boat, it's every bit as passionate. So here the submarine's being pulled out of a hangar. This happens typically in the morning, 7 o'clock-ish in the morning. We try to keep things very routine. 3 people in there, all of them wondering, should they go to the bathroom one more time, usually? Because it's a long day. It's a 10-hour day inside that submarine if you're going down full ocean depth for the sub, 4,000 meters or so. Over the side you go, and no matter how many times you dive, right here, it's a special moment because you're leaving that surface, you're leaving the sounds of the surface, and you're entering the world of the ocean. And you have that lovely color blue that penetrates right into your very being. The divers have checked out the outside of the sub, give you the go-ahead. Once the surface ship says go, down you go to the bottom. And it's, as I said, it's a 10-hour day in the bottom, and about 2.5 hours of it is spent in this each way, 5 hours total spent in that elevator. So 3 people inside there, and on the way to the bottom, you're not hooked to the surface in any way, shape, or form. And as the sub goes down, you leave the surface. After about a half an hour, that blue fades away, and you get into deep blue, dark blue, and then pitch black for about 2 hours of descent. It's quiet. Sometimes you hear the sounds of some animals on the outside, but you do hear the sound of the sonar pinging all the way down to the bottom and back up again. It's giving me goosebumps thinking about it. It's a great thing. Now outside, when you get into the darkness of the deep sea, so 2 miles of water on average, most of it pitch black, we'd say there should be no life there at all. And, oh, I forgot I add these slides. I'll come back to that in a moment. The submarine was great, so 3 people get to enjoy that trip. And then in the early 80s, we started using robots. That's the Jason robot. Actually, it's a second version of Jason, the Jason robot. The beauty of robots is that you can, instead of 10 hours on the bottom, it can stay days or weeks on the bottom. Instead of 3 people looking out the window, you can bring the images up live to the surface and with satellite links. We could sit in a room just like this and drive the robot around the Titanic if we wanted to. There's a lot of debate going on now about whether we should still have submarines or robots, and I'll tell you, it's the same thing as going to a live sporting event or a live concert, is that, sure, it's more comfortable at home, sitting away from the action, you get a better view, you get better sounds, but there's something about being there, about what it actually does to you as an investigator, to you, to your spirit, that you cannot replace. I don't care what you try to do to make it simulate being at the bottom of the sea. It's not the same as actually being there. Some shots of Jason working in the Mediterranean over here. And now we're entering this world where we're using robots, autonomous robots. So we're not actually sitting there driving them from the surface, but we're dropping them off into the deep sea. And this is a robot called Abe. And there goes Abe over the side. Abe looks like the Starship Enterprise because the engineers that designed and built Abe are Trekkies. So it's even got the Enterprise number on it on the front. Now, there goes Abe down to the bottom. It turns out it's a very stable configuration, that having the 3 pods. Now, Abe's designed to what we call mow the lawn. We drop it off on an underwater mountain range or whatever you're looking at, and it runs very neat lines back and forth. So at the end of the day, it gets really down and into the topography. And here we show it. This is an animation of using sound to make very detailed maps of the bottom. You know, if we want to explore, we can't go to AAA and say, well, I want maps of the underwater mountain range, or to Rand McNally or Google. They don't exist. We have to make them ourselves. And Abe is capable of making very detailed maps like this one, where we can point at something. Here, red is shallow, purple's deeper, so there's a little clump there in the middle. So we can point at that map thing that Abe found and say, okay, let's go look at that with the submarine. And it's pretty accurate. In the olden days, you'd be totally lost on the bottom. The other thing we do with Abe, and there's a new version of Abe, I should say, called Sentry, that just now is out in the ocean really getting an incredible amount of work done, is we can either sense for things coming out of the ground. In this case, it's a hot spring, underwater hot spring, or we can take photos. So here's an animation of Abe taking photos. And again, it's very detailed about where it goes. So you can end up with something like this, so you can have a whole football field worth of photographs. And that's something that turns out to be great, especially if you're looking at ancient shipwrecks and things like that. Also good for geology and biology as well. Okay, so we didn't think much would live in the deep ocean, and then when we get in there and start looking around, you start finding out that blanket of water is just full of life, and all sorts of animals. This one, siphonophore, it's a jellyfish. I'll just say it's a jellyfish. It's incredible. It's got all these working parts. It's got fishing lures. It's got stinging tentacles, lots of stomachs, a little jet thrusters on its head, and a little light at its tip. You know, that one's about 10 inches long, fully grown. They can be more than 100 feet long because they keep adding body segments. Jellies that look like they're from space, like something out of Star Wars. And some of these have been captured and are being filmed in a tank. Others, we're taking them right down where they live. But we're getting very good at that, about going into their world, because in the past, if you tow a net through the ocean and pull these up in a net, at the end of the day, you end up with a net full of body parts and mush. And then you have to try to figure out how these animals, what body part went with what animal, and also how these animals may have moved around. So there's nothing like getting in there in the water with them. So, and you can see with the cameras again, how good we're getting pretty good at getting up close to some of these animals. Today, the guy that's building these cameras, Bill Lang, he's doing 3D. So it's not just high def, which is unbelievable to see, but it's also high def, but in 3 dimensions, and it's just glorious stuff. This guy, nicknamed Squishy, the octopus, fantastic little octopus. I love him because you can kind of see through his head. He's moving through the water with his fins, and up he goes. See you around, Squishy. So you know, that midwater region, and in my business that I was in the beginning was geology, so we would pass through that midwater. and see things as we went. And now I love it that we're doing more and more biology in midwater regions. This is off the Bahamas, and we just love this one for the color. That's about, the body there is about 10 inches long, and the tentacles another couple of feet or so. So a beautiful, looks like an electric cucumber or something like that. When you get to the bottom, you have the record of Earth history and also human history, and no better example of human history than Titanic, one big clump of human history sitting on the bottom. And here we are looking at Titanic. This Bill Lang again, and I co-led an expedition. There Jack was king of the world right there on the bow of Titanic. You know, we're getting very, very good at working around shipwrecks. Shipwrecks are not easy to be around. There's lots of sharp edges. There's all sorts of cables and things that can tangle around the sub or around the robot. We're sitting on the bow with in this case, with a robot looking forward. The Titanic hit an iceberg over here to the right. There's a hatch open down there in the foreground. This is what's left of the bridge of Titanic. You know, every single year, about 14 big ships go to the bottom of the ocean. And in the past, we would say, especially if it was in the middle of nowhere, out in the middle of the deep ocean, we'd commit the ship and the souls for eternity to the deep. And that was a lovely notion when we couldn't get there. But now there's no shipwreck beyond our reach. And I think sometimes, more often than not, the families and the shipbuilders, and I know the insurance companies, want to know exactly what happened to those ships. So today, like detectives again, we can go out to the deepest ocean and examine these shipwrecks in incredible detail to find out how it sank. And we've actually done that in the past. These are more close-up views of the Titanic. And I don't know if we go to the, yeah. So here we go, there we are. In one case, there was this British bulk carrier called the Derbyshire, and it sank in a typhoon, I think in 1982, out in the middle of the Pacific Ocean, and we were able to actually go, it had been located, but we were actually able to go out there and take hundreds of thousands of photographs and tens of hours of video and give that information over to the forensic team that could put that ship back together again and figure out just how it sank. So we've gotten very good over the years at understanding how to work around shipwrecks, old ones, ancient ones, but also more recent ones like Derbyshire. And it's something we do very proudly. It's an important thing to be able to do. You know, at some point, we may have to respond quickly to a shipwreck, say carrying hazardous waste, that we need to go out and find it in the deep ocean and decide what to do with it. Okay, so those were, you know, shipwrecks and the jellyfish and all that stuff, the topography, very surprising. Coming back to that underwater mountain range, we were on the moon, I think, in 1969, and it wasn't until 1974 that we first started exploring that underwater mountain range. So 5 years after the moon, we started exploring Earth, and it's a great idea. And when we go to the top of that mountain range, this is what's often what we find. That's a hot spring. It looks like, we call them hydrothermal vents. It looks like hot black smoke coming out of the seafloor, but really it's hot water. The temperature can be, 700 degrees Fahrenheit. Incredibly toxic, rotten, eggy kind of hydrogen sulfide smell. You couldn't get a permit to dump that in the ocean if you tried, but it's oozing out along the top of that mountain range. So all along that 50,000 mile long mountain range, go down in a valley on top and there's this stuff. So pressure there is enough to crush the Titanic the same way you could crush an empty paper cup in your hand. Poisonous chemicals, never been any sunlight. Constant earthquakes and volcanoes. So by all accounts, there should be no life at all, or very little life, maybe some worms. And instead, what happened was some geologists initially stumbled across life, and not just a little bit of life, but an awful lot of life. That's a pillar there that's about 30, 40 feet high, made out of volcanic rock, and it's just covered with life. And now that's a hydrothermal vent community. So almost everything you see there is living in one form or another. This is from that movie, the Volcanoes of the Deep that you mentioned. And Stephen Lowe, this was done with IMAX and with our cameras. So everything you see there is a bizarre form of life. The things that look red, I think they look red or reddish to you. I can't see from here. There's a crab that's going to try to grab a worm and it got back into its shell. So there's tube worms. They can be 5 to 7 feet long, very odd animals. Crabs, clams, shrimp, fish. In one spot, 300 species of life, some 290 plus brand new species. So there's a fish and there's a crab, and the crabs have managed to grab a tip of a tube worm, so they're having a tube worm snack. And the fish and everything else is coming over to have a little bite too. So all this being played out in the deep along the top of that mountain range. You know, in some ways, in diversity of life, the number of species that are here, and in density of life, I mean, look at how many animals in one spot. It rivals the tropical rainforest. So in one instance, we were wrong about life on Earth, about how life likes to live on Earth. What's happening here, the star of the show is a microbe that loves to munch on that poisonous stuff and turns the poison coming out of the earth into food stuff for these larger animals. So it's a microbe that's the real star of the show. It's chemosynthesis, not photosynthesis down here, at least with the microbes. And one of the other neat things is that we think these places get wiped out all the time by volcanic eruptions and other things, and they come springing back into life. So in one way, we think we're looking at the early evolution of life all along the top of that mountain range. Now, those animals are fixed in one spot, and sometimes animals come out of the darkness to have a look at the sub. And this is one of those animals. So this guy looks a little bit like an elephant, flying with his ears. So he's got the very scientific name of Dumbo. This is a Dumbo octopus, 3 feet, 4 feet across, and gliding through the darkness. And you can see the submarine on the bottom over on the right is actually backing up, and Dumbo's coming full speed ahead. The last thing you want in the submarine is to have a very smart, very curious animal like this guy landing on the front of the sub and fiddling with the scientific experiment, doing his own little experiments. What's this little blinking light toy? So anyway, that's Dumbo. And one of the beautiful things about exploring the deep ocean, in the darkness of the deep, is you just never know what's right beyond those lights when you peer out into the darkness. Sometimes it's this. And actually, inside the sub, you've got to be ready to describe something like that for the first time for all of humanity. I mean, there he is, good old Dumbo. I just want to show you a couple of snippets from that was in the Pacific Ocean. This is the Atlantic Ocean. Same deal, top of that mountain range down in a valley that runs along the top. And you don't have here the tube worms, those big white worms with the red tips. You have a bazillion shrimp. These would be the expensive shrimp because they're pretty big. And also you have this incredible structure of these upturned, like, they almost look like little pools, on, almost like a Chihuly glass sculpture. They're just gorgeous. And the thing I like about this is that the shrimp, you'll see in a moment, actually fly in and out of that hot water. Now, it's not 700 degrees where they're flying in and out of, but it's pretty lukewarm. There's a little smoker right there, and there's a bunch of shrimp down at the bottom. And what they're doing is they're eating those microbes. The microbes are eating the poisonous fluid, the shrimp are eating the microbes. And I love these because you know those birthday candles you can't blow out. I like to think of these as a shrimp you just can't boil. So you could give these to someone and say, here, try to boil these. Not going to happen. I can't boil them. So one of the amazing things about this place is that the shrimp feel those white patches on their back. For a while, we were wondering what that could be. It turns out it's like a primitive eye structure. So it may be some sort of a sensor so they can find their way back to the hydrothermal vent where their food is. I'm not really sure yet. There are people working on that right now. There's a better view of that eye structure. But also, again, Bill Lang's cameras that take us down here and give humanity eyes so that we can start to see those kinds of beautiful animals. This I kind of stole from Bob Ballard's website. I didn't really steal it. I borrowed it. I'm sharing it with you. And it's NOAA website. And I wanted to give you a glimpse of this. There's water down here in the foreground, little beach-like area in the back, and then a little wave-cut place over here on the right cliff. Well, that's one of those underwater pools, and they can be bigger than this. So that's a separate body of water in the ocean. I mean, it looks like it was shot up here at nighttime, but really that's the bottom of the Gulf of Mexico. And we find these in the Gulf of Mexico and in the Mediterranean Ocean, and they can be a mile across and 10 miles long, a mile across. But a whole separate body of water that's in the ocean that looks like it's totally decoupled from the sea above it. I mean, it doesn't diffuse. It's a very crisp boundary. It's got waves in it. There's animals that live in it. It's super salty water. That's how it's a brine pool in this case. And so it's super salty, super dense, and it sits down low. Now, the pilots tell me in one of these cases, they landed on it, on one of these lakes. The sub was floating around on one of these underwater lakes. It was so dense they couldn't go into it. But when they lifted off from that lake, they looked down seconds later, and they could still see the imprint of the submarine in the surface of the lake. So very peculiar, very, very strange place beneath the sea. And on the Bob Ballard, this is from the Institute for Exploration and the Rhode Island Institute for Archaeology, Archaeological Oceanography. A lot more images on that website. You should go have a peek if you're interested in this stuff. Truly jaw-dropping images. On the TED site, you can see video of this, and this is some work that my pal Roger Hanlon does, looking at cephalopods, and it's fantastic. I mean, octopuses, squid, cuttlefish. Roger likes to look at how these animals can camouflage themselves, how they know what they look like to, how if I'm an octopus and I want to hide from you, I have to know what I look like to you against that background, and how they do that very quickly. Then they not only change color, but they change the color of their skin, but they change the texture of their skin. That guy over on the right, fairly big octopus, is over there in that left image hiding in that algae. I mean, it's right there. That's the same thing just seconds later. And you can see this on that if you go to TED.com, you'll see the video of this, but they're just fascinating, fascinating research. So it's not all deep water, even in shallow water. You know, Yogi Berra said you could observe a lot by watching. And we're learning, well, he was right. We're learning an awful lot by being in the sea and not scooting from place to place, but just sitting still and watching for a while how these animals behave in the deep ocean and in the shallow water too. Are there any surprises left? Well, you know, I've said 4%'s been explored, maybe 5%. That's 95% left. And we found in that 4% the mountains, the valleys, the tallest peaks, the rivers, all this bizarre animal behavior. So did we get lucky and just hit on all the exciting places, and the rest of the ocean is empty? And I can tell you that's not true, because every expedition that comes back is coming back with some little nugget. Almost every day that I'm back there, someone will call up and say, you've got to stop by my lab, I've got to show you something. And I'll always say, well, you know, maybe tomorrow. And they say, no, you better come now. And it's always jaw-dropping stuff. There's amazing stuff out there inside that ocean. I said that we're entering a new world. We saw some robots. At Woods Hole and in Alaska and other places, Scripps, Monterey, there are different institutions all working on different kinds of technologies to get us down into the ocean. And it's going to be a fascinating 5 years ahead. I think really amazing, and maybe even 10 years ahead too. Looking into the past, we're not just looking at the present, but into the past. Why? Things like climate change. You know, we talked about tectonic change. The plates are moving. Well, the climate's been changing on this planet for 5 billion years. And the only way we can understand it and to understand what our role in it has been in it as humans is to look into the past. And sediments, corals, ice, tree rings, anything that records conditions over time, either atmosphere or air or water or things like that, can give us a clue to the past. The other thing, probably one of the most important things that we realize today is that on this planet there's 6.8 billion people living on this planet. And from this position in space you can't see us, but we're there. And no matter where we live on the planet, we have an impact on the ocean. No matter where we live on the planet, the ocean has an impact on us. And you say, well, what do you mean? Well, you know, on the shorelines, hurricanes, tsunamis, things like that have a direct impact. And I think 18 of the 20 largest cities on the planet built right on the water or on estuaries. So most of the Earth's population, more than half, live right up against the ocean. If you're away from the ocean's climate change. You know, the oceans have a big role in climate change. I'll show you that in a moment. On the other hand, stuff that we put into our ground, into our farms in Montana, in Kansas, in Nebraska, in the heartland of China, all that stuff, nutrients, pesticides, herbicides, around cities, flame retardants, all that stuff gets into the groundwater, gets into the landfills, leaches out eventually, and ends up in the ocean, and it's devastating stuff. So yes, we're exploring, and yes, that's exciting, but all of a sudden we've got this very important thing to find out what's going on with the ocean. Because everything we see today tells us that the chemistry of the ocean, the temperature of the ocean is changing faster than we ever thought was imaginable. And anyone that's ever had an aquarium knows that you fiddle with the temperature, fiddle with the chemistry, and you're asking for trouble. This is the famous climate change chart, the hockey stick. The past is that level part to the left. This is temperature. Over here is the present day. So this is proxy data, tree rings, ice cores, stuff like that. Here's the present day, and here's the future. We spent the last 10 years understanding that this little rapid rise here in temperature is because of human activity. Okay, that's pretty well accepted by almost everybody. Okay, that's human activity there. Yes, there's a natural cycle, but human activity really gets us to where we are today. So that being the case, then what about the future? And you see the future, the graphs go in different directions. What we need to do is be able to adapt to what's coming next. To adapt to what's coming next, we've got to know what's coming next. To know, we have to understand, and to understand, because it's unexplored, we've got to get out there and explore. It bothers me when I see this. This is the IPCC. They put a big stamp on all these things: glaciers melting, lakes this, animals dying, climate change, fine. But what I hear now, people taking up the cause that the science is done. So now that we know that climate is changing, the science is done, let's get on with the cure. The science isn't done. The science isn't done. And like I said, we spent 10 years understanding that we could change the climate on this planet, human activity, through innocence, through ignorance, sometimes through stupidity. We could change the climate, we did. But the big question is what's coming next and how do we adapt to it? The oceans play a huge role. Climate's about two things. It's about temperature and it's about precipitation. And in both cases, it's the oceans that absorb the heat from the sun. The oceans move that heat around, and the oceans absorb the heat with the atmosphere. Not only that, but the oceans actually absorb some of the carbon dioxide, about a third of it that goes into the atmosphere. So the stuff that comes out of our chimney stacks, a third of it gets sucked into the ocean. And actually when it does, it turns into carbonic acid. So what we've done there is that the carbon dioxide turns into carbonic acid in the sea, and it makes it difficult for animals to make skeletons or shells out of seawater. I just want to show you a couple of quick clips, put things in perspective. This is water vapor, and days are going by this fast. Even when you see a weather map, they show you clouds and no clouds. Well, even when there's no clouds, there's usually moisture in the atmosphere, water vapor. And you can see that the whole Earth is connected, and that's the important thing, is that this whole planet is not that big, and it is connected. And you feel even bad for meteorologists when you look at this thing, because they have to predict where that swirling is going to end up next. That pulsing of clouds you see like over South America, those are because of the daily heating of the clouds. Underneath the clouds, the water is doing the same thing. This is from University of Miami, one of their models. And red is warm water, cold up in the top. This is the Atlantic. Blue is cold water, blue and purple. You see that constant pulsing. Those are seasons, that's summer and winter. And over on the right there, you'll see that little finger of heat, that's the Gulf Stream. That is responsible for keeping most of Europe nice and toasty. So oceans play a huge role in climate. As I said before, there's 6.8 billion people live on this planet, and you can't see us from here. But at nighttime, I don't know if you can dim those lights a little bit. Is it possible to dim these? We're actually adding to the lights on the graph here. At nighttime, the Earth lights up just like those jellyfish light up in the dark of the deep sea. And there's 4 kinds of lights on there, and I will zoom in. This is a company called WorldSat International up in Vancouver, and they've produced this fantastic image. That's North America, mostly white lights, the lights of the developed world, all from electricity. So you can see the big cities, you can even follow roadways, you can even see little cities. If you go over to Europe, same thing. Lots of white lights, pretty much the developed world. The little line down below that you see, a continuous line down here, this is the Sahara Desert. This is North Africa, the Sahara Desert. This little thing way on the bottom, that's the Nile River Valley, one of the most densely populated places on Earth. The red you see up here and down inside here, that's the Persian Gulf, that's Siberia. Those are gas flares in the Persian Gulf and Siberia, the brightest thing from space. I think they've cut down on that in recent years. Now they're using natural gas, but there it is. Now we're across this is Asia. On the right, the white lights of Japan. On the left, China, South Korea over there. But the important thing here are the blue clouds. The blue clouds, all those dots, those are fishing fleets. And we talked a little bit about, we poison the ocean slowly, and through innocence and ignorance, the stuff, caffeine, herbicides, pesticides, over time, it's gotten out into the system, and we've had dead zones. We poison the ocean a little bit by carbon dioxide being absorbed into the ocean, turning into carbonic acid. But the other thing we've done in many, many cases is we've overfished and mismanaged the world's largest fisheries. And that's like a triple whammy for the ocean. Some of it through chemistry, some of it through temperature, and some of it through our own activities. We've made it a pretty difficult place. It's almost like we've waged war on life inside the sea. Now, a lot of that's being turned around by wise management practices, by marine protected areas and the like. So we've learned a lot. So the age of innocence and ignorance, we can put that aside. So, it's the little things that got us into this mess, and maybe it'll be the little things that get us out of this mess. So I want to show you this because those gold lights, those are open fires. That's Africa. And not a lot of white lights. So, and this is the developing world, or the undeveloped world, if you want to put it that way. These are the people that are burning wood and things like that for their energy. And what amazes me is that on a planet that I started saying was the ocean planet, covered mostly with water, the blue planet, planet ocean, that there's about 1 billion plus people living in this world that are clinging to the edge of life. People living in this world that have to walk 5 or 6 hours a day to come back to their village with a jug of water that they know will make their family sick and probably kill some of them before the year is out. How can that be true on a planet with so much water? So one of the things we did was we stripped away all the water on Earth to find out just how much there is. And that big ball on the left you'll recognize as good old planet Earth minus the blue. We took all the water off the Earth. Oh, time's up. Either that or the Yankees won. Time to wrap it up. Now that's the time to wrap it up sound. That's the planet over there on the left. And we took all the water off the Earth, and that gives us that ball to the right. That's all the water on the planet. That's all the glaciers, all everything, groundwater, you name it. That's it. And then the little speck on the right of that is all the fresh water. So that's it, right there. And 98% of that stuff comes pretty much eventually out of the ocean. So for us to live on this planet the way we like to live, you have to take that little bit of fresh water. You know, if the Earth was the size of a basketball, all the fresh water would be the size of a ping pong ball. And the fresh water would be just a little pinch. So it's got to go in the right places at the right time in the right amounts. Some of it in the glaciers, in the snowpack, some of it in the groundwater, some of it in the lakes and rivers and streams. We can't have it divided same amount every day. You know, it's got to be just in the right times. It's an amazing sensitive system. And this shocked us when we did this. But when you think about it, the Atlantic Ocean's 5,000 across, 2 miles deep. Pacific Ocean, 10,000 or so across, depending on where, 2 miles deep. You know, the water on this planet is thinner than the skin on an apple. There's not a lot of water on Earth, and there's very little fresh water on Earth. Precious, precious stuff. Here's the latest thing I did. I started thinking about, well, how many people are on the planet, because you can never see them from space. So I'm sorry to have to do this to you, but this means something. I'm not sure exactly what. I found out that the average volume of a person is about 15 cubic feet. And so I multiplied that by 6.8 billion. And then you get that number on top, 147 billion something. That's all the people on the planet. I'm sorry, the top one, 102 billion. Cubic feet. Then you look at a cubic mile, it's 147 billion cubic feet. So what this is saying is that all the people on the Earth, if you put them, I spent a lot of time in airline seats in the past month, put them in an airline seat, we all fit into a box that's a mile by a mile by mile, 6.8 billion people. How is that possible? It doesn't make a lot of sense, but it's true. And I'll show you the footprint of that box that's Anchorage. You can see it from just above Anchorage. This is about 1.5 miles above Anchorage, 25 miles above Anchorage, gone. And you certainly don't see it from here. The impressive thing is that if you think of us just like organisms that we scrape together in one little pile, that we fit into this mile by mile by mile pile, that our behavior has managed to change the chemistry of all that ocean and all that atmosphere on a global scale. That's unbelievable when you think about it. And it's not even all those 6.8 billion people. It's like 10% of us have done that, the developed world. Amazingly sensitive system. Now we got to put it back. And at Woods Hole, you know, we're not advocates. We're not an environmental organization. We're a scientific organization. We just like to put the facts on the table. And right now what we see are the facts and the emotions are starting to join up, because what we see going on in the ocean today, it doesn't take a lot of emotion in there to realize that we need to make some important decisions pretty quickly. So the 6.8 billion people living on the planet, the big question is, what do we do next? And this is the famous blue marble from NASA. We've been given this great perspective of looking down on this planet. And with computers, you know, it's amazing with our technology. With our telescopes, you can see infinity in space. With our microscopes, you can see the material structure right down to the subatomic level. With our computers, you can stop a raindrop. You can walk around a lightning bolt in 3D and examine it. You can speed up continents and watch them collide. So we've got this incredible ability to examine our own world. The question is, what do we do with that information? And I love this quote. It's by Marcel Proust. It says, "The true voyage of discovery is not only in seeking new landscapes as it is in having new eyes. It's looking at this planet that we've taken for granted for so many years, and for the first time, starting to think about it differently. Thanks very much. Thank you. Thank you. Oh, thank you very much. That's kind of you. Oh, go on. You're too sweet. Thank you. Thank you, thank you, thank you. You're going to make me blush. Thanks, sir. Thanks very much. Sorry.
Thank you very much. I think we have time for questions.
Oh, no.
I think we have over 10 minutes for questions, and what we'd like you to do is if you have a question, please raise your hand. We'll bring you a microphone. You don't need to stand up, but it would be nice if you did.
And you can't be a scientist.
And you can't be
No,
a scientist. So wait till we give you a mic.
Yes, sir.
I'm from the humanities.
Okay.
Dumbo had eyes.
Yeah.
How does he have eyes?
That's one of the great questions. You know, when I talked to this guy named Tim Shank, one of our scientists that best knows, at Woods Hole anyway, these communities in the deep. And a lot of the fish have eyes, some of the crabs have eyes, some of the shrimp have those eye spots. Why? And in a world that we think is pitch black to us. And there have been some studies done with looking outside the normal frequencies of our light that say that there might be this low-level light coming out of the vents, like a night light, so they can find their way back. The real answer is we don't know yet. But that's one genetic adaptation. You know, we've got animals there living in the dark that have eyes. We've got animals thriving in a carcinogenic soup that are thriving. I mean, the density is just amazing of the animals living, and they're thriving in that. How do they do that? Why do they do that? So those are some of the questions we need to understand. So I don't mean to dodge the question, except that's a very good one. Very good one. Yes, ma'am.
Why don't the animals in the deep get crushed like a can?
Why don't they get crushed like Titanic? I mean, Titanic wouldn't get anywhere near that deep, and even at the surface, after it started sinking, within a few hundred feet, it was mashed to nothing. They're smart enough that they don't have any thing to collapse, so they don't have any sort of swim bladders or air bladders that the ocean can crush. You know, we do this wonderful thing on submarines, and people that go into submarines do this often. Take a styrofoam cup, which is mostly air, and you decorate it on at the surface with Sharpies, put it on the outside of the submarine and take it to the bottom, and the ocean will gently squeeze every bit of air out of that, but it does it in a way that it squeezes from is this my phone doing? Sorry about that, buzzing. It does it in every direction because it's hydrostatic, and so at the bottom you end up with this little tiny coffee cup, gentle. At Starbucks it'd probably be $9.95 for a on the other hand, you could have a very expensive piece of equipment that's in a titanium housing and have some sort of a scar or a scratch, and the ocean will crush that in a heartbeat. So what animals have learned to do is to build these bodies that can resist that. They just don't have anything to crush. The crabs that we see at those vent sites sometimes come up to the surface, climb into the sub, onto the samples, come up to the surface, and they're fine for a day or two. So it's not so much the pressure that bothers these animals. When they do die, it's often the thermal shock of coming up to the surface. And you know, actually we're very careful these days too about what we sample and what we don't sample, about how much noise we make or don't make, and how much light we bring and don't bring to the bottom of the sea. But that's another great question. Great question.
Hello, hello, on your left, the engineer on your left.
Yes, sir.
Joseph Campbell taught us to ask, what myth are you living, or what myth are we living? Do we humans, in figuring out how we belong here, have a myth problem? Are we living an old myth? Do we need a new one? You think about that ever?
You know, I've never been asked that. That's a great question. I think we are living a myth. Yeah. I don't think we got this right yet. I'll put it that way. I really don't. I think and the thing about climate, when I see these discoveries being made, that we have these dogmas, plate tectonics was one, that the continents could move. Who would have thunk that? You know, well, you got to be kidding me. That life was found in the deep sea, which biologists right away said impossible, impossible. You know, it's not possible to have life in and not only little tiny animals, but big animals, not only just a few, but thriving. I watch these things collapse, these ideas collapse, and I can't help but think that we got the whole thing pretty wrong. And I don't have the answer yet, but I just think there's something more. I also, on the technology side, by the way, I watch us, I go to this TED conference, and a big part of it is technology, is faster phones and faster internet and faster and faster and faster and more. And why? What are we racing for? It's not clear. It goes back to what I said about the information's at our disposal, but what are we doing with that information? So yeah, I think we are, but I don't know the answer to it. I don't think we got this right at all. I'll tell you a couple things, just one more thing, and sorry, you're going to get me off. I get really, when I did the climate change thing with Vanity Fair, on the cover of, sorry, Vanity Fair, I'm invited to a Vanity Fair party on Tuesday, so I better watch what I'm saying. On the cover of the Vanity Fair, to get people to pay attention to climate change, Vanity Fair, by the way, is dead serious, the editor, Graydon Carter, about making a difference on this planet. But on the cover, they put Leonardo DiCaprio and a polar bear cub that they photoshopped in. Why? Because people like polar bear cubs, and we don't want polar bear cubs to drown. Here's the thing. There's 1.8 billion people today that we're not trying to avoid climate change. We're living climate change. It's happening around us. It has not stopped. It's around us now, but already on the planet, we got 1.8 billion people. If that doesn't move us, that polar bear shouldn't either. There's people that they're not that far away. It's a quick plane ride over to that part of the world where these people are truly suffering. The other thing is we talk about losing a major city to a major storm because of climate change. What about New Orleans? It happened. We go, oh, that's different. That's unfortunate, but that's over there. And so I think part of it's. What I worry is we've become hypocrites. I'll put it that way. We've become very hypocritical. I go to many of these green movement meetings where they serve Fiji water. Well, I understand that Fiji water sometimes looks nice to have that glistening bottle on the table, but trucking, shipping, and flying water from an island in the South Pacific to Los Angeles doesn't make a lot of sense to me. So I'm a little bit worried that we're approaching a nation of hypocrites, and that we want to appear concerned, but when it comes time to really make a difference, and it doesn't have to be radical, it just has to be in the right direction, as far as I can tell. I don't think we have that. And a big part of it is we don't know what to do. And I find that, and I don't know exactly what to do. What should I be putting on my lawn and not putting on my lawn? What should I be burning in my car and not burning? What kind of, I just don't know. It's not clear to me. And I know it's not clear to a lot of scientists too. So I worry about stuff like that we're so hooked on the media that we get all our input from the media, and the media doesn't have time to figure out what the right thing to do is. Sorry, thank you. No. Yeah, I hate to say it, but it is the little stuff. It's the little stuff that will get us out of this mess.
I see another question on this side.
Have you seen that floating plastic?
Oh, the big giant island the size of Texas.
Do you think we'll ever solve that?
If you go to the Pacific, I don't think you'll find an island the size of Texas. That's another thing. The media heard floating island the size of Texas. Let's run with it. There's a lot of plastic in the Pacific Ocean, and it's not like it's Pepsi bottles floating around out there that are piled up. It's a molecular stuff. It's horrible. It's really, really, really bad. It's just when I think of. No one wants oil spills, but the oil spills, the media loves oil spills because it's horrible. You have dead animals, they're soaked in this black, ugly, gloppy stuff. There's the boat off the shore. It's an event. There was someone to blame. They hate that. But what's worse than that is the steady trickling of crystal clear water off of our farmlands that's carrying with it death, herbicides, pesticides, all that stuff to the ocean. The runoff of rain from our golf courses is pretty green. Everyone wants green golf courses. That stuff's worse in many ways than the oil spill. Now, I'm not saying oil spills are okay, but this stuff is worse. But the media doesn't focus on it. The plastics are focused on the big things and the rings that getting around and choking animals. Yes, that happens. But the stuff that you can't see is worse. And we need to focus on that too. So we need to switch away our. But there's no big giant island out there that we can. Build golf courses on or anything like that. I'm sure someone thought of that. Island in the Pacific, let's start building. It's not out there. But there's a lot of plastic in the Pacific, and it's scary stuff. Yeah, in the Atlantic too, a lot of plastic. You know, in the deepest, someone asked me what the strangest thing I've seen at sea. And we just sent a robot to the deepest part in the Pacific, and they found a trench coat. And the funny part is it was in a trench that they found it, so what else? In the middle of the Atlantic Ocean, out in the middle of no place, where ships hardly ever go, in the middle there's a tire from a car. A tire in the middle of maybe it fell off a spaceship, I don't know. But there's one out there.
I have a question about ocean acidification.
Yep.
As we learn more about the shifts that are happening, it doesn't take but just a few changes in the pH to make monumental changes
Yeah.
in the marine ecosystems, and you've got coral
Exactly.
reefs dying and everything.
We do.
But on the flip side, the more you explore, the more you find out how much diversity and what
Yep.
an incredible world there is out there, and you've got this life
Yep.
around sulfuric vents.
Sure.
Is there real hope for adaptation here, or are we all?
Well, you raise a very good
Yeah.
point. Everything is rhythms and cycles, and there's a natural rhythm and cycle that goes something like that, and it's happened for a long time. And by and large, life has managed to adapt to these big, long rhythms and cycles, or you go extinct. But anyway, life adapts. It's these rapid things like us dumping in all this chemical junk or changing the acidity rapidly, where life doesn't have a chance to adapt. So you have adaptations, and instead of a certain fish, you have just jellyfish move in or something like that. It's not good. Will we survive it as a species? Yeah, probably. People that say the Earth will die, we're killing the Earth. The Earth will be fine. It was fine without us. It'll be fine without us in the future. But what's happening is it's in our own best interest, and it's in the best interest of people and animals like us that we start to take better care and understand what's going on. But that's a very good point, though, about can life adapt? I don't know. You know, but it's everything I hear every time I talk to the people working on acidification is that the change is faster than they ever thought was possible and more serious than ever possible.
So I guess I just have a question. What would be, you can pick the number, I was thinking of 3 or 5 simple things that we can do that would be the most effective changes.
You know, the easy cop-out to that question, what can you do, is for me to say awareness. Unfortunately, that probably is also true. If you check an organization like IPCC, the climate change, they've got a lot there. Oceana, there's a lot there that you can do. NOAA's got a website that tells you a lot you can do. You know, I think we have to learn more about what should go and shouldn't go onto that we should put into the atmosphere and into the ground. Herbicides, pesticides, that kind of thing, nutrients. I think we need to, some decisions have to be made about that, and probably that's what's going to make a change is if we make the change through the marketplace. So if you start buying things that are grown in a certain way, I'm just guessing that. So again, I have to cop out. The cop out's awareness. I mean, and we have to reduce emissions. I'm a horrible example of that. You know, I'm flying all over the planet. I FedEx stuff because I can't get it all done or sent out in time. So I'm FedExing. You know, if there's a book I need, I'll FedEx it tomorrow, even though I won't read it for a month. I've learned what I don't want to be is a hypocrite. I think that's the most important thing. Is let's not be hypocrites and think that because we changed one bulb or maybe we drive a Prius that's enough. There's probably going to be a little bit more that we have to do. Yeah. That doesn't answer your question, I know, but that's where my brain is. I don't know what to do exactly. There are places on the web that'll give you 10 things. You know, there's one place, and this is kind of gross, but it's the truth. What they said is we should have a national pee outside day, where everyone, instead of using a bathroom, will pee outside. Now, some places that make sense. In New York City, that makes no sense. In Boston, that makes no sense, and it doesn't make a lot of sense, you know, but on one hand, you say, okay, that's what I can do, but no, it's not. It's not a good idea. Not a good idea. Yeah.
I think on that note, maybe we'll take one more question, and then you've been talking all day.
Well, Dave's ADD is acting up. Let's get the riddle and dart gun out.
All right, well, here's the last question. Thanks. Oh, sorry,
I can't speak for Alvin and Woods Hole, but I know virtually every dive that Bathscaphe Trieste made,
Yes, sir.
they found junk on the bottom.
Yes, they did. I was going to mention
Aluminum
that when I mentioned the trench. That's
Beer cans, pop cans, bottles, sinks, toilets,
Yep.
helicopters, airplanes.
You know, that's a
lot
very
of
good
stuff.
point. The Trieste was one of the deepest diving subs. In fact, the anniversary of the trench dive that Don Walsh and Picard made coming up, there's a big celebration in January.
It's coming up in April.
Pardon?
The reunion's in April.
Oh, there you go. Yeah, that's a good, and Don Walsh is still having a blast out there. So that's a very good point, that even in the very deepest sea, you know, I've underplayed it because I'm thinking there must be some dive where we didn't see some record of humanity, but I can't think of any. There's always something. Yeah. Yeah.
I said one more, but I promised this fellow one.
I'm
so this is
here till my flight tomorrow morning.
I'm just wondering who, aside from the Americans, are doing any significant work in this area?
Yeah.
And is the information shared?
Yeah, who aside from the Americans is doing work and is the information shared? America, through our genius, is now slipping to, in deep submergence, we're slipping behind countries like China, Japan, South Korea. So our submarine, for instance, Elven, is 40-something years old. We need desperately to have a new submarine. And try, you know, one space shuttle, not to take anything from space. Space exploration is very important. But one shuttle launch is almost equivalent to a whole year's worth of oceanographic research, all of it. So it's lopsided. We can't get, you know, we're having a hard time getting a new submarine to replace Elven, 40-something years old. But still the most productive submarine in the deep ocean, more productive than the new submarines. But China has made a commitment to the deep sea. Korea has made a commitment to the deep sea. Even Russia is still committed, even though they have all the problems that they have. They're very committed to understanding the deep ocean, and other countries are as well. So we're sliding backwards in that world. It's very humbling to see that. Is information shared? Yeah, I think pretty much it is. I mean, the Intergovernmental Panel on Climate Change, they're meeting again in Copenhagen. For the first time, the climate meeting's recognizing that the oceans are very important. So the group that came, that Kyoto, this year it's going to be in Copenhagen in December, and the main attraction is the ocean's role in climate change, which is about time. You know, that's pretty important. So the answer is a lot of people doing work, and hopefully the U.S. will wake up and we'll be able to lead the pack again. But we'll see.
Well, thank you so much, Dave,
Thank
for
you.
coming and talking.
Thank you very much. Thank you. Thank you. My honor. Thank you. Thanks. Thank you. Thanks. Thanks very much.